Hello everyone, welcome to Chem 9 lab session. This week we are learning about lipids. So in this week's lab we will learn about physical and chemical properties of lipids. So let's take a look at the experimental procedure about this lab. So lipids are a group of biomolecules which are soluble in nonpolar solvents and are insoluble in water. Lipids play many different roles, which include energy storage and creating cell membranes, etc. Lipids are mainly classified into two categories. So first category is fatty acids, and the second category is the steroids. So fatty acids are those lipids which include a long chain of hydrocarbons with a functional group. In fatty acid, the functional group is carboxylic acid, so that's why it's known as acid, hence the word fatty acid. In steroid, all steroid molecules contain a characteristic 4 rings structure. Fatty acids are further divided into or further subclassified into 4 categories. So first category is waxes. In waxes we have an ester group in the middle, and on one side of ester group we have a long fatty acid chain, and on the other side we have a long chain alcohol. The second category is triacyl glycerols. In triacyl glycerols we have a glycerol backbone, and we have 3 fatty acid chains connected to the glycerol backbone. In glycerophospholipids, again we have a similar glycerol backbone, but it only has 2 fatty acid chains, and on the third side we have a phosphate and amino alcohol functional group. And finally, sphingolipids. So these are the main categories of lipids, and in this lab we are going to take a look at various physical and chemical properties. In physical properties we are going to look at their appearance, their solubility, and similar properties. Some of important lipids are listed in this PDF file, and I would highly encourage you to read through these instructions. The structures are also given, and physical properties of various lipids and fatty acids are given. For example, lauric acid, which is one of the fatty acid, the length of carbon chain is 12 in lauric acid, and it is obtained from coconut oil. Its melting point is 44, and its chemical structure is also given. Similarly, physical properties of many other fatty acids and other kind of lipids are also provided here. One of the chemical property we are going to look at in today's lab is the chemical reaction between glycerol and fatty acid molecules to create triacyl glycerol. So this kind of molecule is known as triacyl glycerol. In this reaction we have a glycerol molecule, which is shown here, and one glycerol molecule reacts with 3 acid molecule. Now 3 fatty acid molecules. In this example we are using stearic acid, but it could be any other fatty acid also. It could be lauric acid, myristic acid, or even linoleic acid. Any acid can be present. So 3 of those acid molecules will react with 1 molecule of glycerol, and in this reaction hydrogen atoms from the OH group linked to glycerol will be removed, and the OH group from the fatty acid functional group will remove. So this H and OH will form water, or H2O. Because there are 3 of these functional groups reacting, so hence 3 molecules of water will be lost and a new ester linkage will be created. So this kind of reaction is known as esterification reaction, and the end product is known as triacylglycerol. These are also known as triglycerides. Another chemical reaction which we will look in this week's lab is the reaction of various fatty acids or triglycerides with bromine. So this reaction is actually used for checking if there is unsaturation present or not. Now, meaning of unsaturation is if there is any double bond present within the fatty acid or triglycerides or not. So for example, if you look at various fatty acids, some of them, they do not have any double bond, such as here, but some fatty acids, they do contain 1 or more double bonds, as you can see here. So any fatty acid or any triacylglycerol which contains a double bond will react with bromine to give addition reaction. So in addition reaction, the double bond will break. So as you can see, the double bond here, it breaks, and instead 2 bromine molecules will be added wherever the double bond is broken. Now, the beauty of this reaction is that it will show whether a double bond is present or not. Bromine itself is dark brown or yellow color liquid, and the fatty acids are colorless. So when we add bromine to the colorless, if bromine is added to the fatty acid, or in other words, if the double bond is present and bromine will be added, then this will become colorless. So in other words, addition of dark brown bromine will change to colorless solution if the double bond is present. So this color change is used as an indication for checking the presence of a double bond. So we add the brown bromine. If the color of bromine disappears, that means double bonds are present. If the color of bromine does not disappear, that means bromine is not reacting, so double bonds are not present. Another thing to notice here is if the fatty acid contains multiple double bonds, the color of bromine will disappear faster or more rapidly. If it contains only 1 double bond, then the color of bromine will disappear slowly or will not disappear completely. So these are chemical reactions and physical properties which we are going to look at in today's lab. So let's take a look at lab report. So lab report of this week's lab is given here. So let's open this. So the data needed for this week's lab is already given to us. So when you open the lab report, so first section is the physical properties of lipids and fatty acids. So the physical properties are already filled up, so you don't need to fill these values here. Remember, lipids are those which are soluble in organic liquids, and they are insoluble in water. And as you can see, all of these are insoluble in water, so therefore they are all classified as lipids. But now we need to know under what category these lipids fall. So for example, stearic acid, we have to choose whether stearic acid is a fatty acid, triacylglycerol, steroid, or glycerophospholipid. So the answer of this can be found here in the PDF file. So stearic acid is given here, and we can see that stearic acid falls under the category of fatty acids. So therefore you will select stearic acid as a fatty acid. Similarly, find what category other compounds belong to: oleic acid, olive oil, safflower oil, lecithin, and cholesterol. So all of these compounds are listed here. So for example, you can see cholesterol is a steroid, right? So here in cholesterol you will select steroid. So choose appropriately what type of lipid it is. And the next is, why are the listed compounds classified as lipids? And as we learned that lipids are those substances which are insoluble in water but soluble in non-polar solvents, such as dichloromethane, which is shown here. So that's the reason why these are classified as lipids. Next section is about triacylglycerols. Prepare or look at models of glycerol and 3 molecules of ethanoic acid, then answer the following question. So in this case, identify the functional group in glycerol and ethanoic acid. So you need to identify the functional group in glycerol. So if you look at the structure of a glycerol, so glycerol structure is given here, and its functional group is OH. So you need to write what is this OH functional group. In ethanoic acid, see, we are using stearic acid here, and remember, in all organic molecules which has COOH functional group, so those are classified as acids. So you need to write the name of this functional group which is found in ethanoic acid. It is found in all organic acids, so write the name of those functional group. Then in the next section you have to write down the reaction between glycerol and ethanoic acid to produce the products. So the reaction is similar to this reaction. Let me erase. In this reaction, glycerol is reacting with stearic acid. All you need to do is, instead of stearic acid, you need to use ethanoic acid. So find the structure of ethanoic acid and replicate this reaction, and then upload the structure, or upload your reaction here. Next is the diagram of hydrolysis of glycerol triethanoate by drawing the condensed structure formula of the reactants and product. Upload the image of your equation. So this reaction is exactly opposite of the reaction which you did here. So the product of this reaction will become the reactant here, and the reactant of this reaction become the product. So essentially, whatever reaction you uploaded here, or uploaded or written here, opposite of that reaction will go here. So the reactants will become products, and products will become reactants. And finally, the testing of unsaturation. As we learned, unsaturation is a reaction in which we add bromine to various fatty acids. If a double bond is present, then the color of bromine will disappear. So for example, in this case, stearic acid, we added bromine, the bromine color remains. That means it is saturated. Only unsaturated fatty acid will make the color of bromine to disappear. So for example, olive oil, the brown color disappears, and that means that olive oil does contain double bond, hence olive oil is unsaturated. So here we have to draw the condensed structural formula of stearic acid and oleic acid. The formula of stearic acid and oleic acid are given here. So just find the formula and draw it and upload your answer here. Next is stearic acid or oleic acid more unsaturated? Whichever contains more double bonds is more unsaturated. And also explain using the bromine test results. So use the bromine test result which are given here to explain your answer. And finally, you have to compare the unsaturation of safflower oil and olive oil. Again, you have to use the results of unsaturation reaction or bromine reaction to explain whichever is more unsaturated. And once you answer all these questions, hit submit, and that will be the end of the lab report. If you have any question, please feel free to contact me by email or during office hours. Thank you for watching the video. Have a wonderful rest of the day.